Today we're going to be talking about end-to-end testing, specifically with Playwright and test containers. So we're going to explore a bit how you can write or use these tools to write tests that are both reliable, but also actually mirrors the real environment that your code runs in. So no more mocking away the complexity and all of the external dependencies. We're actually going all in, and we're going to embrace it and making it everything work for us instead of against us. So my name is Santi, or Vemund, as they usually call me in Norway, but nobody manages to pronounce that name correctly. You were very good at it, actually. I'm currently working as a consultant, as a tech lead / full stack developer at my company Capra, which means the goat in Latin. I have a background from having worked in some of Norway's largest companies, but also one of the absolute smallest startups there is. So I once founded my own company, and as you can see, I'm no longer the CDO of that company, so that didn't go that well. Nonetheless, it was a really great experience, and you really learned that way what actually matters when it comes to running production code and what you really need to focus on when you're shipping your code into production. So I actually realized while making this presentation that I worked with test containers since I actually graduated from the university. So apparently I like it a lot. Not necessarily just in Python, it's also implemented in a lot of other languages. But in this talk, we're going to focus on the Python implementation of it. And I actually liked it that much that I started contributing to it. It's a community-maintained fork back in 2024. Then I got my t-shirt and became a maintainer of the library. So with all of that in mind, let me hear a bit more about you. So I want to have a bit of a hand raise here. I want you to raise your hand if you feel that you have a good unit test coverage in your code base. That's less than half, and I'm not really looking forward to the next question. Do you have good end-to-end coverage in your code base? Still a few people. And who has actually used test containers and Playwright for that? Okay, so if you used one of them, that also qualifies. All right, great. So a lot of people don't really do this in their daily job, and that's good. Then you're going to learn something today. And for those of you that have used all of this before, hopefully you're going to learn something as well. There are, of course, lots of things and tricks and what's actually hiding underneath here that you can dive into. So just to take a bit back to the basics, let's cover the background and what we're actually talking about. So this is the testing pyramid. Hopefully you've seen this before. If you haven't, you should look it up. It's very useful. It's just one way to categorize your testing into different categories, where you start usually from the bottom with or as little complexity as possible, but it also gives you less actual confidence in what you're actually testing. So at the bottom here, we have what we call unit tests, usually tests for a single function or just a single piece of logic, making sure that it actually runs okay. Super low complexity setup. This is usually what you get in most of the testing libraries when you install them. They are meant specifically for that. It does not really give you any big guarantees in how those units will behave together with other units. But you can be pretty sure that at least this small unit of work actually works. In real life, of course, things are much more complicated, and it naturally involves a lot more interaction between the different components in your system. So I would argue that if you want to be sure about your system actually working, unit tests are not enough. So moving on to integration tests, that's basically just multiple layers of logic or chunks chunked together. Usually a bit more complex to actually set up due to you usually have to mock a lot of dependencies that you don't want to care about. You need to kind of, depending on how you set up your code base, it can be difficult to actually do it. If you use dependency injection, it's super easy, but we're not going to cover that today. And then at the top here, we have our focus for today, the end-to-end test flows, which tests your whole system from your initial user interaction all the way to the backend and back into the user again. And that can include multiple jumps between servers. It can use external dependencies from cloud providers, for example, or databases, and so on and so on. It's usually quite hard to set up good end-to-end tests, and due to this, most people actually run them usually in like a staging environment or dev environment, where you can be quite sure that it mimics kind of what is going to be in production. But I want to do it before we actually merge anything into one of the branches that's deployed to staging or a development environment. So just to also give a disclaimer, I'm talking a lot about end-to-end testing. It's not a holy grail. There are very good reasons for making or focusing on making more unit tests, or maybe just making some integration tests and be happy about that. But I do think that you should at least think about this and think about what you're actually missing in your testing rig without actually running end-to-end tests. So to give you the background, or to build actually our little world here, we're going to be testing a lot of different applications that we're going to run in parallel and then do end-to-end testing on them. So our universe looks like this. We have a core API. It's a Python fast API server. It communicates with a Postgres database because, of course, you choose Postgres if you're going to have a database. We have a front-end application called user admin, written in React with a React router, just so that we have another layer actually where or React router can run the server-side rendering mode, so that you actually have a server rendering your HTML before you actually get it served to your client, and then it hydrates on your client. So there are multiple steps as part of this rendering process as well. And just to add a bit more complexity, we'll have another API that's communicating with our core API service called user API, and it's going to be communicating asynchronously with Kafka, not just an HTTP request. So here we have a lot of snacks that we need to figure out how to actually run these things locally on our computer. And this is where most people would say, I'll just deploy to our development branch, and I can use the Kafka cluster there and our Postgres database. But instead, we're going to add test containers to provide us these external services. Because this test containers makes this all possible. There are, of course, other ways to do this as well. You could just run up some Docker containers locally. It's basically Docker containers all the way down in test containers as well. You could use some Docker compose file, but then you would have to manage the life cycle of those containers outside of your testing code, which is not really ideal. I would much more rather just be able to type Python run tests, or Poetry run PyTest, for example, and then the code automatically figures out what do I actually need to spin up in order to actually be able to test this. So in this case, we're going to be using some test container modules. But before then, we're actually going to jump a bit into more details about test containers. So test containers is basically just a wrapper on top of Docker. It provides a lot of Docker services. There are ways to basically just do Docker through test containers. It also supports Docker Compose in some of the implementations. And there's a whole host of just community modules that's not necessarily made by me. It's made by everybody else. They have their own repositories where you don't need to be an expert in test containers in order to write a community module. So for example, a Postgres container, that's not made by the test container team. It's just made by some maintainers from Postgres. So if you have a good idea for a container that you want, or you have a need for an external service that you would like to be supported in test containers, you can write it yourself. It's not really that difficult. And why do we do this? Because this SQL code, for example, in our, as I mentioned, I have a bit of a love relationship to Postgres. I do a lot of Postgres things in my daily job. This SQL code would probably run in most SQL databases. But if you're not using test containers, there's quite a high chance that you would probably use something else to replace your Postgres server when you were running your tests. For example, using an SQLite database. And this thing would probably run in an SQLite database. Also, most ORMs would probably run in an SQLite database, but it's still not really the same. You don't have like the same guarantees that if it's running in SQLite, then it runs in Postgres. You want it to actually be sure that it runs in Postgres. This is actually a concrete example from my current contract. So this runs. This probably runs. I haven't tested it. It's a common table expression. I do think SQLite actually supports it. And this definitely does not run. And this is actually production code that I have where I'm currently working. This is using a lot of Postgres-specific things. You have left join laterals, you do JSON-B aggregation, and so on and so on. Lots of optimizations just to make it run in Postgres. It does not run anywhere else, which is okay, as long as we have a Postgres database to use. And luckily, Testcontainers provides us that. And Testcontainers provides us those containers in a super easy way. It's a one-liner. You just import the Postgres container, you define which Docker image you want, and you start it. Now you suddenly have a Docker container running Postgres on your system. And you can also get the port, the username, the password for your container, or from your database, just from this Postgres object. Super easy. And this enables us to actually do this fully locally. You don't need to deploy it to any cloud services. You don't need to push it into a specific environment or run lots of things on your own computer. I actually sat on the plane here from Norway to Prague and did local development because I just had all of my test containers and I didn't really care about not having an internet connection. And as I mentioned, it integrates with test cycles. So during your tear up or setup and tear down functions, you can just start and stop your Postgres container. They already cache the image locally, so it takes a few seconds and then you're good to go. Here, for example, here's a specific example from PyTest where you just have a Postgres picture, you start it, you yield it, and you stop it. You don't need to think about it anymore. So how does it work? I mentioned that there is actually, instead of turtles all the way down, it's actually Docker containers all the way down. So let's look at a concrete example of the life cycle of a test container. So you have your Python process, and you do this line of, you create the Postgres container, you start it, and then the first thing you actually do, you don't start a Postgres container. You communicate with the Docker registry, and you start another container, which is called Ryuk. And this is part of the thing where it goes a bit away from the standard Docker compose setup. Because Ryuk, he looks like this. He's actually an anime character from Death Note or something. I don't really know the background of it, but if there's any anime fans, you've probably seen this guy before. We call him the Reaper. And he is responsible for killing all of your containers that you are not managing anymore. So then the next thing you do, then you actually start your containers. You start your Postgres container, you start your Kafka container, and you can get your connection information from them and use them in your program. And then you're done. So your Python process shuts down. The connection to your Ryuk container, it breaks. There's a socket sending heartbeats back and forth all the time. And then as part of your setup, you actually register that I also have some other containers here. So Ryuk actually knows about these two other containers. So once your Python process is gone, Ryuk contacts the Docker daemon. The Docker daemon then sends some SIGINT signals to your other containers. They disappear. And as a good god of death, I think it's called, he also reaps himself when he's done. And that's your cleanup in your test containers environment. Unless you actually choose to just opt out of this and stop your containers by yourself. So back at our setup, in our testing environment, we have some containers. They are managed automatically, either by Ryuk or by your PyTest feature teardowns. But we're still missing kind of a crucial setup that we need in order to actually be sure that we're testing things that are actually user behavior in your app. Because our app is user-facing. There is actually a user clicking through that browser and doing some stuff. It's probably opening some menus, typing some stuff in, and submitting some stuff that would you probably go through all of these different layers and end up in your database. And it is possible to kind of test a lot of these things because of the user admin application probably has some endpoints where you can just post things. You can either post form data or some JSON probably, and you can be quite sure that at least like the integration between all these different layers, they work. But you don't really know if a user is able to do what they are expected to do in your app. For that, we need something else. For this, we're going to use Playwright. So Playwright is a browser automation tool. It makes it possible to actually simulate a user in your browser by actually clicking on things and finding things in your HTML and then clicking on them. It's also possible to use it in combination with just some HTTP requests. In our example here, we will use both because the user API does not really have a user or a browser interface. It's just an API. But it will also click through things in your actual browser. So let's go into some details about Playwright. What is it? It's a browser automation library. It works quite well on all of the on macOS, on Windows, on Linux. It's implemented in multiple languages, and the Python implementation is quite featureful. It's not as good as the TypeScript implementation, but it's kind of getting there. And it gives you a super easy API to just interact as a user with a browser. As I mentioned, if you're also doing .NET and Java, that's also fully possible to use the Playwright library. Everything is made by Microsoft, so I would like actually some specific features if it was possible in Python. So if you are working at Microsoft on Playwright, please contact me afterwards. It would be very nice. And it does not matter what actually your applications are or what language your applications are written in. We have now 2 applications written in Python, 1 in TypeScript, and a lot of other things happening underneath the hood. But it does not really care. It's just a standalone application that's written in one language. It doesn't need to be the same. So if you prefer to write your tests in Java, that's also fine. It supports all major browsers, Chromium, Firefox, WebKit or Safari, even Edge. Or Edge is really just Chromium under the hood. And it also supports a real Chrome distribution. It's not really built in, but it's getting there. And you can also even generate tests by just recording your user input, which I will show you, which is super handy. And you don't really need to figure that out that much from the API itself. You can just record yourself clicking through your app, and this is now my test case. And of course, it integrates with PyTest. So you don't need to switch your testing framework just to be able to use a very nice API. So back in our test environment, this is what we're going to do. We're going to write, or I'm going to show you some tests interacting with your browser and your backend APIs. They will communicate with each other. And we might even write another test while we're up here. So I'm going to give you a live demo of this. Let's hope the demo ghost doesn't visit us today. So I've been told to use a white theme or a light theme for all code shown on these slides today. So just to give you a quick introduction to what we're basically doing here. I have our core API application. As part of the setup function, our main function here, we start some containers. This is probably not what you want to do in production code because you don't want to run your containers in production code, of course. But for now, just this example, it works. So you start your test container, Postgres container, Kafka container, and you get the connection string from the container. You start some database pools, and you set up some fast API endpoints. We have our user API, which is a lot simpler. This one doesn't really start a Kafka container. It just uses the one that's started by core API. There are ways to share this in an easier manner, because now you really depend on core API starting before user API, but that can be, you can come around that if you want to. So this one connects then to the Kafka cluster made by core API, and that's how it's going to communicate. And lastly, you have just a front-end app user admin with some routes in here, for example, showing that, yeah, you get some HTML served to you as a user, and you have some functions here that actually interacts with your backend. So let's look at some tests. I've already started everything running in the background here. So the first thing that we could do is just to run our tests and see if they actually work. So we try to just run our tests, and voila, it actually works. That's nice. Let's do something a bit more interesting, because if you enable the debug mode for Playwright, you get a lot more interesting interfaces. So here we have, it actually spins up a Chromium browser for you, and then it shows you your tests. So here's the test case that we've written in our end-to-end code. And I wanted to step one piece or one line at a time through this testing code. So let's do that. This is our users list. It focuses on an item you want to find on the page. So this time I'm getting a heading which has the name no users found, and you expect it to be visible. So there's our first actually expect statement. You expect when you open the page for the first time that there are no users there. Let's go a bit further. You click on the Add User button. You click on the full name input field. You fill in some data. And you click on the email field. You fill in some data. And then you click the Add User button. And a user appears. And then you expect there to be at least one list item down here, which contains the text, Vemund, and my email. And you expect it to be one of those. So let's go further. We have another test. Just gotta find the other browser window here. So we have another test. Let's just run through it, and everything passed. So that's a very, very easy way to debug even your tests. Because if you just write out using the Playwright API for, okay, I expect it to be a title on the page or some text containing this and this, and it just fails because I didn't find it on the page, then you really have no clue what's actually happening on the page unless you look at it. So this one lets you actually look at it. Last one I want to show you is what I mentioned about how to actually produce a test without writing it yourself. So let's go back to our terminal. We're running Playwright here with CodeGen, and you just point it to your web page. Then it shows up on my screen, so I'll just move it a bit. Here we go. So you get a familiar interface. This is going to be your test code, and then you click record. And in this case, I want it to be a bit bigger. So yeah, let's make a test just checking that if you try to add a user. So I click on that one, then it records. You click on the button with add user on it. If I enter some information, Nicholas, for example, and some email, but then I decide, yeah, maybe I'm not going to do that anyways, and I click cancel. Then I would expect in our next test for there not to be a line here. Now there's still this last picture from our last test, but if we were doing this from a fresh database state, then there would be nothing here. So then everything I basically need to do, just copy this test, create a new file, paste it in here, and then you just add some expect statements here. For example, you would expect this one, not clicking it, but instead to have count 0, for example. And you could add some even more tests or assertions along the way if you wanted to. Yeah, so that's basically it. It's, we now have our full end-to-end rig. You don't really need to write that much of testing code. You initially just need these 2 lines of starting your test containers, and then you're done. So, thank you.
Thank you, Vemund, for the talk. And do we have any questions for him?
Yes, great talk. I've never used Playwright before, so it looks very nice. The only thing I'm wondering is, shouldn't the web browser things also be in containers? Because now it expects things to be installed. So how is this run on a CI?
Playwright fixes that for you, actually. So there's one command, Playwright install, and then the browser you want. It can be all browsers if you want.
That's great. Thank you.
My question was about the actual test containers themselves. So can you actually mock data and like initialize the database to a certain state?
Not directly through test containers. It only provides you the actual service, but then as part of your probably setup code and tests, then you could populate your database. What I did in this example was that I had a fixture that initially started my container, and then I actually deleted the data from the users table because you don't need to have to go through the API, because maybe the API doesn't have an endpoint for deleting all your data. It probably shouldn't. But if you can connect directly to the database and just delete a table from there.
I have a question. How does Playwright compares with Selenium?
Playwright, I would argue, is kind of like the next generation of Selenium. It solves kind of the same problem. It was developed by Microsoft because Selenium was not really good enough for their use cases. So it does the same thing. It just provides you a cleaner API, basically.
Maybe one more. If you target certain elements on the website, I saw you are addressing them by selectors, like a header and so on. So you don't use like IDs for that?
Preferably not. I wouldn't like to add an ID to every single element that I have on my page just so I could test it. I would rather the API works by identifying the different like types of components that you have. And if you're not able to, for example, find a button, that's probably a good chance that you are using some wrong semantic in your HTML. And then that also hurts screen readers and accessibility engines. So you go by the selectors using the role of the element on the page, but you could also do like test ID selectors or even CSS selectors, I think. But prefer to go by actually. Excuse me, could you repeat that?
In React, everything is div, if I remember correctly, right?
Not everything needs to be a div in React. There are lots of developers using only divs, but it shouldn't be only divs. It's just fine to have a normal button element in React rendered code as well.
Yep, okay. Thank you for the talk. Great talk. I had a question about these test containers. Is your local setup for testing differs from the one that you use in CI?
If my local containers differ from the ones I use in CI?
I mean, you invoke them via Python API, right?
Yep.
And how do you integrate this in the CI? Do you also invoke them in the CI, or you use native CI tools for this?
I also invoke them in CI. GitHub Actions, for example, they give you a Docker socket that you can connect to, and that's basically all you need. And as I showed you in the code, then I actually started in the main application. Don't do that. You have instead like a separate entry point where you spin up the containers, and then they just provide you dependency inject the actual configuration to your app, and then you start.
And then I have a follow-up. What is the main benefit in comparison? Like, I can basically set up the same environment using simple Docker Compose that I can use for my local development, and I can also use for tests, right? What would be the main benefit of using test containers in this case?
Main benefit is that you integrate it, so it's only one single command. You don't need to like open two separate terminals, do something else, and it also follows the life cycle of your application. So when you shut down your application, your containers actually stop. And it's also in your tests, if you could start these containers multiple times, and then you will get a clean slate. That's usually beneficial when you're testing Kafka, because it's not really that nice to delete a lot of topics when you're using the same topics over and over. So then you could just you don't really need to care about stopping and starting Docker Compose in between tests. That's just part of the test that you set up your environment.
Got you. Thank you.
But I would argue, yes, Docker Compose also does a lot of the same things.
Thank you.
I'm sorry we have run out of time for more questions. Thank you all for joining us. Thank you, Vemund. Thank you.